Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to draw Lewis dot structures when you're given the formula. In this video, I'm going to show you the steps you go through to draw your Lewis dot structures. There are 5 steps, and I guarantee that if you follow these 5 steps, you should get the right Lewis dot structure no matter what. So let's get started. So here for the first one, we have Ni3. And so the first step is always going to be calculating the total number of valence electrons. So remember, the valence electrons are determined by the number of the group that the element is in. And so we're looking at the main group elements. So the 1A, the 2A, those A groups. So the number of the A group indicates the number of valence electrons that your element has. So here we have nitrogen. So if I have nitrogen, then that's going to be in group 5, so that has 5 valence electrons. And iodine is the other element, and that has 7 valence electrons because it's in group 7A. So, and I have 3 of them, so that's going to be 3 times 7, which is 21. And so 21 plus 5 gives me 26 electrons. So that's step 1. I've got my total number of valence electrons. And step 2 is to draw your skeletal structure. Now, when you draw your skeletal structure, what you're going to do is figure out what the central atom is and bond the other atoms to that central atom with one bond, not double or triple bonds. That'll come later at later steps. So we're going to just connect the atoms to your central atom using one bond each. So we have to figure out what is your central atom. So there's a couple of ways to do that, or there's more than one way to do that. So first, usually the first element in your formula is the central atom. So here we have nitrogen written first, so nitrogen would probably be our central atom. The other thing you could look at is electronegativity. Normally, it's the lesser electronegative atom that is going to be your central atom. If you look at nitrogen compared to iodine, iodine is more electronegative compared to nitrogen, so therefore you would assume or suspect that nitrogen is going to be your central atom. Also, you would look at the relative numbers of these elements, right? So here I have 3 iodines. Here I have nitrogen, only 1. The one you have less of is usually going to be your central atom. And then finally, you can look at the dot symbol for each element and see which one has more unpaired electrons in your symbol. So if you look at nitrogen, for example, so nitrogen has 5 valence electrons. So if you put the dots around your symbol, 1, 2, 3, 4, 5, you'll see there are 3 unpaired electrons. If you take iodine, iodine has 7 valence electrons. So if you do the symbol for iodine, 1, 2, 3, 4, 5, 6, 7, you'll notice that iodine has 1 unpaired electron. So this can bond once, and this can bond 3 times. So the element that has the greater ability of bonding is going to be your central atom. So that's a few ways to figure out what your central atom is. So obviously it's going to be nitrogen. So if we put nitrogen as our central atom, we're going to bond the 3 iodines to the nitrogen. And so that's step 2. Now that I have my skeletal structure, let me make sure this is good. Now I need to subtract the electrons that I used for the bonds. So I use 2 electrons for each bond. That's 3 bonds, 6 electrons. So I'm going to have to subtract 6 electrons from my total here. So subtract out 6. I have 20 electrons left. Now to step 3. Step 3 says that I must add lone pairs to my outer atoms first to give them an octet. So My outer atoms are iodine, so I'm going to give them 3 lone pairs to give them an octet, because each iodine already has 2 electrons from the bond, so they need 6 more electrons for the full octet of 8. So this one will get 3 lone pairs, and then this one will get 3 lone pairs. Okay, now I've done step 3. I need to subtract out the electrons that I use. So I use 6 for each. 6 times 3 is 18. So I'm going to subtract out 18 more electrons. And that gives me 2 electrons left over. Step 4 is next. So step 4 says if you have any electrons left over at this point, all of them will be going to the central atom as lone pairs. So I have 2 electrons left over. That means I have 1 lone pair worth of electrons. So I'm going to add 1 lone pair to my central atom. So now that I've did that, I need to subtract out the 2 that I used. And now I have no more electrons left over. At this point, you can double check and make sure that your Lewis dot structure is correct, that everyone has, or every atom has an octet, except for those who don't need an octet, like hydrogen, for example. So again, we've already shown that each of the iodines have an octet because they have 1 bond with 2 electrons and 3 lone pairs at 6 electrons. So 2 plus 6 gives you 8. And that's the same for these. Now your nitrogen has 3 bonds. That's two electrons per bond. That's 6 total, plus the 2 here. That's 8. So the nitrogen is happy with its 8 electrons. So all of the atoms are happy with an octet. So we're done at this point. So we don't need to go to step 5, which would be if the central atom needed more bonds or needed more electrons, then we could move electrons from the iodine to create double bonds. But iodine's not really going to do that, and nitrogen is fine with 3 bonds and 1 lone pair. And also, I want to point out at this point the common bond patterns here. So nitrogen, being in group 5, has a common bond pattern of 3 bonds and 1 lone pair. Iodine, being a halogen, in group 7 has 1 bond and 3 lone pairs. So that they fit the bonding pattern. So that's another thing to look out for. Bonding patterns won't always hold, but it's a good thing to see if they have the correct bonding pattern. Okay, so what about B? So let's go ahead and erase this, give us some room. So here, B, I have a C2Cl6. So how do I do this molecule? So same thing, I'm going to start with the number of valence electrons. So I got to calculate that. So carbon is in group 4, and I have 2 of them. So carbon, being in group 4, has 4 valence electrons. I have 2. 2 times 4 is 8. And then I'm going to add to that, well, here I have chlorine. Chlorine is in group 7. So that's 7 valence electrons for chlorine. I have 6 of them. So 6 times 7 is 42. So 42 added to 8 equals 50. So I have 50 valence electrons for my molecule here. So now I'm going to use those 50 electrons to create the Lewis dot structure. So that's step 1. Step 2, create my skeletal structure. So I'm going to go ahead and write it down here. So I have C2Cl6. So now this one might be a little complicated, or it might seem a little bit complicated, but always remember, the central atom is usually the element that's written first in the formula. So here we have carbon written first, so it's most likely going to be the central atom. Also, again, we could look at the electronegativity, right? So chlorine is more electronegative than carbon, so carbon is the lesser electronegative, so that means that it's probably going to be the central atom. Also, you can look at how many times it bonds by looking at the number of unpaired electrons in the Lewis symbol, right? Carbon's going to have more. And you can see chlorine, we have more chlorine than carbon. So this one is probably going to be the outer atom. Carbon's going to be the central atom. Now, the thing that might confuse you is that we have two carbons. So both of them will be the central atoms. We'll have more than one central atom. The carbons will be bonded together. So we're going to go ahead and create our skeletal structure using this. So the two carbons are going to be bonded together, and then we're going to bond the chlorines on both of the carbons. Now, what I said before in my last video is you always want to pay attention to symmetry. Symmetry is going to be a guiding principle when you're making your Lewis dot structures at points, especially if you have multiple central atoms. So here we have 6 chlorine, so I'm going to add 3 to each carbon. Okay, so now I've got my skeletal structure. So now I'm going to remove the electrons that I used. So I used 2 electrons per bond. Here I have 1, 2, 3, 4, 5, 6, 7 bonds. 7 times 2 is 14. So I'm going to subtract 14, and that's going to give me 36 electrons left over. Now that step 2 is done, I can go to step 3. Step 3 is add lone pairs to the outer atoms to give them an octet. So that's the chlorines. So I'm going to give the chlorines 3 lone pairs each because they already have a bond, and that's 2 electrons. So 3 lone pairs will allow them to have octets. So here we go. 2 more. 1 more. Okay. So now my chlorines all have octets. They all have 6 lone pairs. So I got six chlorines, 6 lone pairs each. 6 times 6 is 36. So if I subtract out 36 from 36, I get 0 left. So at this point, I have no more electrons. So step 4 would be that if I had electrons left over, I would add them to the central atoms. And again, if you have electrons left over, you would add them if you need to symmetrically. So if I only had 2 electrons left over, then I would have to put a lone pair on one of the carbons. If I have 4 electrons left over, I would have 2 lone pairs to give, and I would put a lone pair on each carbon, a lone pair on each carbon. But in this case, I don't have any electrons left over, so I can't do step 4. So at this point, once you have 0 electrons left, double check your Lewis dot structure at this point and see if it's okay. So here we're looking for every atom having an octet. So we already said that the chlorines have an octet, right? We have 3 lone pairs, that's 6 plus the bond, that's 2, that's 8. So that applies to all the chlorines. What about the carbons? So the carbon here has 1, 2, 3, 4 bonds. 4 times 2 is 8, so that's good. And this carbon has 1, 2, 3, 4 bonds. 4 times 2 is 8. So all of the atoms have an octet, so therefore they're happy, and then we're done. We don't have to do any more steps. So that is the Lewis dot structure of C2Cl6. Okay, what about B? H2O2, hydrogen peroxide. So again, let's erase this, give ourselves some room. So again, the first step is going to be adding up all the valence electrons. So hydrogen is in group 1, that's 1 valence electron. I have 2 hydrogens, so that's going to be 2 total from the hydrogens. And then, I'm talking about hydrogen and I'm pointing to the carbon. So again, carbon is in group 4, has 4 valence electrons. I have 2 of them. 4 times 2 is 8. I don't know why I was talking about hydrogen. So that's going to be 8 electrons from the carbon. For Oh, I know why. I'm confusing myself. I'm looking at the wrong one. So I was talking about H2O2. So yeah, I was right the first time. So hydrogen is in group one valence electron, and I have two of them, so that's two. Oh my gosh, I gotta stop doing that. Okay, so now I have oxygen. I have two oxygen. Oxygen is in group six. So that's going to have six valence electrons. I have two of them. 6 times 2 is 12. And I add those together, and I have 14 total valence electrons. So now that's step one. Step two, skeletal structure. So again, I have two elements, and I said usually the first element written in your formula is going to be the central atom, but here's an exception because hydrogen is first. Hydrogen will never be a central atom, so you can always ignore hydrogen because hydrogen only bonds once, and that's not going to make for a very good central atom. You need something that's going to bond more than once, a lot more than once. Um, so hydrogen is ignored, so that means that leaves oxygen. Oxygen has to be the central atom. Notice we have two of them, so they're going to be bonded together, and then both of them will be the central atom. So here I'll write on this side, I'll put the two oxygens together. And then what about these two hydrogens? I could bond both hydrogens to one oxygen, but again, symmetry. We want to pay attention to symmetry. So if we have two hydrogens, we want to have a hydrogen on both oxygens. So we'll have one there, one there. Looks like a pair of glasses. Okay, so now that we have our skeletal structure, we're going to remove the electrons we used from our total. So we used 2, 2, and 2, so that's 6, 3 bonds, 2 electrons each. So we're going to remove 6, and that means we have 8 electrons left. That's step 2. So now step 3, we're going to add electron pairs or lone pairs to our outer atoms. Well, what's our outer atoms? We have hydrogen. Hydrogen is okay with only 2 electrons or one bond. It has one bond here, that's 2 electrons. Hydrogen is happy right now, so it doesn't need any more lone pairs. So we can skip step 3. So step 4 says if you have any electrons left over, we add all of them to our central atom. We have 2 central atoms, so we're going to add lone pairs to both of them. And again, we're thinking symmetry if possible. So this oxygen has 2 bonds, so it's going to need 2 lone pairs for an octet. So I'm going to put 2 there. And this oxygen has 2 bonds, so it's going to need 2 lone pairs for the octet. So there we go. I gave an octet for both oxygens. And so how many did I use? I used up 2, 4, 6, 8. So I'm going to remove 8, and I have 0 electrons left. So at this point, again, whenever you have 0 electrons left, you look at your Lewis dot structure, make sure everything's fine. And if it is, you're done. So here, hydrogen, as I said, is fine with only one bond, so that's fine. And then for the oxygen, we have 2 bonds, 2 lone pairs, that's 8. 2 bonds, 2 lone pairs, that's 8, right? Because there's 2 electrons in each bond. And so 2 plus 2 plus 2 plus 2 is 8. So both of the oxygens are happy with an octet. So this is our final Lewis dot structure. So we don't need to go on to step 5 for this one. Okay, so that is H2O2. And then finally, we have C2H4. So again, we got to look at adding the valence electrons together. So here I have carbon, which is in group 4, as I said earlier, group 4. So 4 valence electrons, 4 times 2 is 8. So that's going to be 8 plus, and here I have 4 hydrogen. For each hydrogen is in group 1. That's 1 valence electron. So 1 times 4 is 4. And so I add those together and I get 12 electrons total. So that's step 1 is done. Step 2 is skeletal structure. Again, notice that I have hydrogen and carbon. Hydrogen will never be a central atom, so it's got to be carbon. carbon, I have two of them, so both of them will be the central atom. So I have more than one central atom bonded together. So I'm going to bond them together. And I have 4 hydrogens. So I could put 3 hydrogens here and 1 hydrogen in there and try to do it that way. But it would be much better if I divided up the hydrogens evenly so I get symmetry. So here I can put 2 hydrogens on this carbon, and I can put 2 hydrogens on that carbon. So that'll work a lot better. So now that I have my skeletal structure, I'm going to subtract out the 2 electrons for each bond. So 2, 4, 6, 8, 10. So I'm going to subtract out 10, and that's going to leave me with 2 electrons left over. So step 3, if you have electrons left over, then add them to your outer atoms to give them an octet if they need it. Notice that all of our outer atoms are hydrogen. They don't need an octet. They're fine with their single bond. So we don't need to worry about step 3. Step 4, if we have electrons left over, all of them will be put onto the central atom or atoms as lone pairs. So here we have 2 electrons left over. That's 1 lone pair. I can put the lone pair here. Oops. As I was saying, I can put the lone pair here on this carbon, or I could put it here. It doesn't matter because I only have 1 pair. So I'm going to just put it here. And so I used up those 2 electrons. So I have 0 left. So at this point, I look at my Lewis dot structure and I see if everyone's happy. Well, the hydrogens are happy with their single bond, so nothing to do there. And then this carbon here has 3 bonds and 1 lone pair, so 2, 2, 2, and 2. That's 8. So this carbon's happy. But this carbon only has 3 bonds, no lone pairs. So that's 2, 4, 6. So this carbon only has 6 electrons. It should have 8. So here we have to go to step 5. Step 5 says that if you have no more electrons left over and your 1 or more of your central atoms do not have an octet, then you need to move lone pairs from your outer atoms or from another atom to create a double bond so that you can get that octet. So we only have 1 lone pair, so that's the only one we can move. So we're going to have to move this lone pair and have it shared between the 2 carbons as a bond. So then we create a double bond. Like so. And so now I have a double bond between the carbons and the hydrogens are the same. So now if you look, you see that this carbon here has 1, 2, 3, 4 bonds. 4 times 2 is 8, 2 electrons per bond. And then this carbon has 1, 2, 3, 4 bonds. So again, that one's going to have now 8. So now both carbons are happy with an octet. This is the Lewis dot structure for C2H4. And that, ladies and gentlemen, is how you do or create or draw your Lewis dot structures from the formula. I hope this is helpful. If you enjoyed this video, if you learned from this video, then please, by all means, like the video, share the video with your friends. Also, make sure you subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. If there's a video or topic or problem you want me to do or solve or help you with, then please, by all means, share that with me, and I would love to do that for you. Thanks for joining me, and have a great day.